In recent years, the multimedia principle has been recognized as one of the most well-established principles of learning that can be applied to education. This e-lesson focuses on helping you better understand what makes the multimedia principle an important tool to improve human learning. After completing this e-lesson, you will have a working knowledge of the multimedia principle, learn when and how to best use graphics in your presentations, and identify the target audience that best responds to the multimedia principle. These two works by Ruth Clark and Richard Mayer were used to create today's e-lesson on the multimedia principle. By definition, the multimedia principle states that people learn more deeply from words and relevant graphics than from words alone. By words, we mean printed text, such as words printed on the screen that people read, or spoken text, such as words presented as speech or audio that people listen to. Types of graphics include static illustrations, such as drawings, charts, graphs, maps, photos, and dynamic graphics, such as animation or videos. The multimedia principle can also be referred to as the multimedia effect. The reason to include both text and graphics is that people are more likely to learn the material when they engage in active learning or relevant cognitive processing. When a presentation includes both words and graphics, we refer to it as a multimedia presentation. Multimedia presentations help engage active learning by helping students make connections between the text and graphics. Based on cognitive theory and research evidence, it is recommended that e-learning courses include words and graphics instead of just words alone. Not all types of graphics will help learners understand the material. You're looking at a list of different types of graphics, which we will discuss in depth over the next few minutes. Knowing when and how to use them is what helps your learners develop a deeper understanding of relevant content. Decorative graphics only serve to decorate your presentation or add humor, but do not enhance the message to the learner. As you've probably noticed, the picture of the penguins on this slide does little to enhance your knowledge of the multimedia design principle. Try to minimize the use of decorative graphics so that you can incorporate graphics that will help the learner understand the material, such as transformational and interpretive graphics, or graphics that organize the material, such as organizational graphics. Representational graphics are visuals that illustrate the appearance of an object. They can be used to help show facts or concepts, but they don't give the learner a deeper understanding of the material. Again, their use should be minimized so that you can incorporate graphics that do help the learner understand or organize the material more effectively. Relational graphics show a quantitative relationship between two or more variables. They can be in the form of a line graph, pie chart, a map, or like this bar graph that shows the high school GPA on the x-axis and the percent on the y-axis. In addition to showing relationships, relational graphs can also help teach a process, which is a description of how something works. Organizational graphics show the qualitative, not quantitative, relationship of its content. Examples of these types of graphs include a matrix, concept map, or like this tree diagram that shows the university structure of UALR. Organizational graphics can also be used to teach facts, concepts, categories of objects, events, or symbols designated by a single name. A transformational graphic can be an animated demonstration, a video, or a time-lapse animation. The example shown in this slide is the time-lapse metamorphosis of a butterfly. Transformational graphics can be used to show how a description of something works, which is a process, a series of steps resulting in completing a task, which is a procedure, or guidelines that result in completion of a task, which is a principle. Interpretive graphics make an intangible phenomenon visible and concrete. These types of graphs can be in the form of a diagram with arrows that shows the blood flow through the heart, or images that show how data is transmitted through the internet. The image on the screen shows the molecular structure of water. In addition to transformational graphics that we talked about in the last slide, interpretive graphics can also be used to teach a concept or principle. If it is important to add graphics to words, is it better to use static illustrations like the ones we displayed on the previous slides, or animations? A number of research studies have failed to find that animations are more effective than a series of static frames depicting the same material. The table on this slide covers some main points we will discuss in the next 2 slides. A static illustration requires the learner to engage in active processing in order to mentally animate the changes from one frame to the next. Here is an example of a transitional static graph that depicts the stages of a thunderstorm. An animation or video would not force the learner to participate in active learning. Furthermore, the use of animation or video may not allow the learner to control the order and pace of mental processing. Additionally, if an animation or video is used, reality might be distorted for the learner because the stages of the thunderstorm would likely be accelerated. There is some evidence that animations or video may be particularly helpful for tasks that require complicated manual skills. The video you're about to watch is an example when the use of a video is appropriate for the learner. The video shows how to perform a complicated motor skill, how to tie a bowline knot. This might be particularly difficult to do with text and static graphics. However, it is important to note that you still run the risk of potentially overloading the learner's working memory because the images and the scenes are so rich in detail that the learner may not be able to hold the scenes in his or her working memory.
In this video, I'll be showing how to tie a bowline knot. What I'm first going to do is put a loop into this side of the line. Now taking this end of the line, I'm going to go underneath and through this loop, and then around this side of the rope and back through the hole. That is our bowline knot. The easiest way to remember which direction to twist the loop in this line and the fastest way to make this knot is to take the end of the rope in 2 fingers, go over this line, and spin your fingers around. Now you'll have this line coming through the hole already, and this loop will be in the proper direction. You now just come around there and back through the hole.
The information acquisition view states that teaching consists of presenting information and learning consists of acquiring information. According to this view, as long as information is presented, the format doesn't matter. In the knowledge construction view, learning is seen as a process of active sense-making, and teaching is an attempt to foster appropriate cognitive processing in the learner. With this view, instructors must guide the learner's cognitive processing and encourage the learner to actively participate. The knowledge construction view aligns itself to the multimedia principle. An important part of active processing is to mentally construct pictorial and verbal representations of the material and to mentally connect them. The goal is more likely to be achieved when multimedia lessons contain both words and corresponding pictures that work together to explain the same to-be-learned content. This goal is commonly referred to as a multimedia effect, which finds that people learn more deeply from words and graphics than from words alone. You may be asking yourself, is the multimedia principle right for everyone? It's been shown that the multimedia principle works best for novices, which are learners that have low knowledge of the domain-specific content. Studies show that experts, which are learners with high knowledge of domain-specific content, learn equally well with words alone or with words and graphics combined. This is likely due to the fact that experts are able to mentally create their own images from text. Expertise reversal effect implies that instructional methods that are helpful to novice learners may have no effect or even depress learning of high-knowledge learners. This concludes our e-lesson on the multimedia principle and its applications. Here is a summary of what we covered. Take a moment to review the concepts and revisit parts of this e-lesson if necessary to fully grasp the multimedia principle. Remember, people are more likely to understand the material when they engage in active learning. Multimedia presentations are valuable because they can encourage learners to engage in active learning by mentally making connections between pictorial and verbal representations.